Hi, just recently, a guy named Swellington, he made a manual for how to make Visuino components, a third-party ones. So in the newsletter from Visuino, we see here, and he made some tutorial for how to make your own components. Components in Visuino, they looking like this. Is sorted into categories, and you can select and you can drag a component out. And you can connect wires and you can use them. But today we are going to replicate this manual, because this manual is in he speaks in Portuguese in the videos. So I will try to replicate this creation of the components. So I have also, you can see in Visuino's website, he's made a component here a while ago. Some other people, they have also made it. I have made a manual on my website, so one can follow. That will explain things a little bit more in detail, what the different things are. But first we will see how a component is made. So we have a Visuino open, and for editing a component or viewing a component, I will use the Visual Studio Code. And first we will add a folder to our workspace. So adding the document and Arduino and the libraries folder. Then I can see all the libraries we have here. We have a Mitos library that is all the other components that you normally see in Visuino. And for making your own library, you need to make a folder next to Mitos library. And inside there, we need to have some folders, a source folder that will hold the H files. This will have our code, or running code. And we need to have a Visuino folder. And in the Visuino folder, we will have the Visuino components, call it creation files. In this case, I have two here. This file can have several components inside if you have different variations. Like you have a step sequencer, but you have it in different flavors. It can be added several components inside the same file. If we look in Mitos folder and the Visuino, and we look in some component here, there is several components added down here, which is in the same Visuino file. So the library setup is kind of important. Under the Visuino folder, we have the images folder, and it can have a subfolder with a name for the image, and there is a special naming for how the component will use the image. So first, we will take a look at two of the components, how they actually comes up on the board. So these two I made by replicating the manual from Swellington. I will now take these two components As you can see here, these two looks different, and it's in the vcom file where you configure these pins, as you see here. So we will take a look at that. In the FinPulse unit, we have a name. You can see we have a create name. And if we look at the step sequencer, we have the other name here. So these two brackets creates the name. If we look down here again and we hold the mouse over, we can see the step sequencer unit has the name. And then it's a create name, which is this name. Okay. The next we have is the Arduino Include. What this does, it includes the file we have in the source file, which holds the code or the functionality for the component. As soon as we drag a component from the component selector here and into the code, we can look in the pure code, the full code in Visuino that is adding these two H files. When we look at further to the component, we can see that we have a bracket called Arduino Loop begin. And what this does is that when we look into the H file, we can see that we have an inline void and system loop begin here. And when this is added in the vcom file here, as long as it's added here, we can see in the full code and go back to the void loop that this unit will be added here. There is other functions that we can use here. If we're looking down in my manual here, this is the library folder file layout. And you can see that we have Arduino init and start, and Arduino loop begin, and the Arduino loop end. And we can see what they do. So they kind of triggers the routines in different stages, like in the setup and in the loop. And if we look at how the H file is built, we can see that we need to, if we have them, we will have an inline void for system init and the system start and system loop begin and then the system end. So here we put our code inside those. And the reason why there is several of them is, if we're looking back to the Visuino full code again, we have the setup function, and we can have the init first and we have the start after, and we can also have declarations that we have in start of the loop and then in the end of the loop. It's depending on how we run them. It will link and use the inline void for the different parts. So, but in this case, we only have the system loop begin. Looking back in the vcom file again, we have the Arduino class here. So as you can see in the H file, we define under the namespace, we define a class name. We define the output pins like this. And then under a private section, it can be private or public. we define the variable we want to use, and then again it can be private and it can be public. And then we have under our system loop begin, we have our code running, and we have some code here. This will act as an event handler. So let me explain that. If we look in the finpulse vcomp file, and when we come down to this part here of the code, we have the input pin and we have the output pin. This is the names for the pins, and after the colon we can see what type of pins they are. If we, for example, change this digital pin to an analog, it will show up as an analog pin here instead. So we can look, we have the other component here that has many more pins. So let's take a look at that. We have that vcomp file here. So here I have different namings for the start and these other pins. And here I selected these types of pins. And for the output pin, it's a source pin. So here we can see that it's a sync pin and it's a source pin, depending on if it's in or if it's out. And it can be digital and it can be analog, it can be color pin, different parts of pins. So this part actually creates the component with the pins that we see in the image here and here. We have a bracket here called category, and from this part until this part we can add the categories where we want them to end up inside the different categories we can see here. So now when we have assigned our pins to our components here in the vcomp file, that means that the design of the component is ready. Then we see that we include this file, step sequencer H. If we look into this file, we need to design them like this for the output pins. This is also explained better in the website. So here we can see the different pins we have and how they are built together. Shows a little bit of what these are and the pins and how we use the inline for the different parts. So I will improve this a little bit better at a later stage. So here this is how we assign the output pins into a program. This tells that is an output pin to Visuino inside the H code. We can assign our boolean or variables, different variables here, and then we add our codes inside the system loop again. So in a regular Arduino code, you will have declarations of variables at the top, and then you will have the system, the setup will come, and then the loop will come. So in this code, this code here, we add the actual physical code, and when something comes in on the input pins here or here, we have these types of commands. So what this does, you can see that the start of the name here, before the O receive is the actual physical name we have for the pins we have created as input pins. And the left part, the right part here, it will be that is a kind of an event handler. So as soon as some change coming into these pins, we will execute this void here. And in my case here, I just take the data coming in and I just push it to the declared variable we have here. So this is how the input pins works. They are designed like this for the component view, like this and this. And the functionality for these the input pins and output pins. The input pins we assign like this. Easy to just replicate and make more of this, but they need to look like this. Just changing the names for these different pins you have. The output pins we write to them by using this command here. So this is a command that is more hidden into the Mitos H file in the system, but it's a way that we write to the output, which is declared by this function over here. And we write the output value. So in our code, we are running our code here, and we're setting some output values into our variables here, declared variables. And then the way to write the output code is declared here. So it's quite easy to make the components yourself.